Good morning again. I am Pradnya, and as I mentioned during the overview of workshop, basically the goal of this workshop is to make every one of you able to develop some small applications for Akash tablet. So at the end of this workshop, we expect you to come up with some nice educational applications for tablet, and definitely, I mean, Phatak sir has already given you incentive that there will be a cash prize and a lot of other things. So definitely, please help us to build a Akash community which will contribute towards the educational applications. So let's start this great cause with a great introduction. Yeah, so the introduction, see, basically the introduction to Android would be like FYI session for you. It will, I mean, tell you what all happens behind this great, cool technology. So in students' language, it will be a like theory lecture hai yaar achhi neend like nikalenge. But I will promise you that I won't torture you that much. I will minimize my torture from my end. So please bear with it. So let's start with it. So the contents which we will cover is the introduction, what is Android, etc. The Android version and API level. Very important point as a developer to know what your device supports, which version and API level. A very important part. Otherwise, your application won't run on device. A big picture is nothing but how Android stack looks like. Then the comparison of Dalvik virtual machine and Java virtual machine. This Dalvik virtual machine is a very interesting part what Android people came up with, and this is why Android is so fast. Then next is Android features, some out of box feature what Android provides. Then application fundamentals. We have .apk file which we install on Android device. So what is this .apk? We will look into that. Then Android application components. These are basic programming building block. So as a developer, you will always deal with these. So this is important for you to know. So let's go next. So what is an Android? It's a well-known Linux-based OS, primarily for touch screen mobile devices like smartphones, tablets. It was initially developed by Android Inc. and then purchased by Google in 2005. So in Google started working on DVM in 2005, and then after 3 years they came up with first Android device in 2008. And rest all is history. All of us know how popular Android is today. Next, Android is open source and Google releases its code under Apache 2 license. Now this is an important feature why Android is so popular in the market, because it's an open source. So, and it is released under Apache 2 license. What Apache 2 license says is, you derive your code from the original work, you can use it for any purpose, you can modify it, you can redistribute it. So whatever these hardware manufacturers are like HTC, Micromax and a lot of others, what they do is they just customize the Android for their own purpose and they just redistribute it. So the cost for this is zero. No licensing, no paying of royalty, nothing. So that's why Android is so popular in the market, because of the cost saving. And last is the Google Play Store. A very useful place for you people. If you want Angry Bird app for your Akash tablet, this is a place you should visit. Basically, you will have all kind of Android applications at one place, which is a Google Play Store. You just think of anything and you will have app for that. So, open Android. What it means to be open and why would you care? So basically I have given this link. I am not sure whether it is visible for you or not. This is the Apache 2 license link. So those who are interested to do that, you can go and check out what is the terms and conditions to do it. So what do you mean by it's a open Android? As I had already told you, it's a open source. Google is releasing its code under Apache 2 license. You can use this code for free of cost. Nothing need to be paid. So, that's why it is so popular. The brief history of Android, this is basically just for reference when different Android version came into the market. Like if you just glance through this, in 2009 it was from Cupcake to Eclair, then 2010 from Froyo to Gingerbread, and if you just observe, these are like alphabetical names of desserts. I don't know what made to them to make this desert names. If you see that this is a picture representation of these versions. This is still what we had till 2010. Now then in 2011 it was Honeycomb, then ICS, and our Akash tablet have ICS version. I will show you how to check the version of the device. And 2012, the latest update is Jelly Bean. Let me just go and show you. So again, a representation, all desert names they have provided. So yeah, so this is about the versions, and next is the API level. So what is this API level? Basically, API level is a unique integer identifier for API framework. Again, now what is API? This is application programming interface. So in normal language, API is nothing but you will have lots of classes, lots of attributes to use, which you can use in actual code. So these, why do they need, an revision of API? So definitely with each API level, there will be some plus minus, and then they have come up with a revision of each API level. So whenever new API comes into the market, it's always an additive change. The old won't be removed, it will be deprecated, which means there is something new, better available in the market which you can use. So if you try in the Eclipse editor and something comes as a strike through, if you try a class name and something comes as a strike through, like a new notification manager class, so that's a deprecated one, and if you get that, that's a, which means that there is something better available in the market which you can use. So in new API, the better has been made available for you. So what I want to emphasize on is the API is an additive change. Old won't be removed, but yes, it may be deprecated. So for each version, there is a corresponding API level. So for our Akash tablet, we come at this level, that is 4.0.3, and API level is 15, and version name is ice cream sandwich. And the rest all is for your reference. I have mentioned the all versions and corresponding API level. You can go through it later on, depending on device on which you want to code, you want to support your applications, you can go ahead with it. This is nothing but API level grouping based on the need why it developed. The first API was specially for smartphones, then the 3.0 to 3.2 came for tablets, and from Android 4 onwards, Android is everywhere. Let it be smartphones, tablets, just think about it and it is there. So let's move ahead. The choosing API level, why I mention it is important, because it depends on device support. Basically you need to know your device is on which version, and corresponding API level, so the application in corresponding API level will only work on the device. And there is something called as application forward compatibility and backward compatibility. This is pretty logical. So for example, if I have a device which has a version 4.1 Jelly Bean, and I compile my application using 4.0, that is ICS, so it will work on my device, but vice versa may not be true, which means I have a device which is 4.0 and I compile my application in 4.1, and if I try to run on device, it may not work. For obvious reason that each API has an additive change, something new. If you have used that new functionality of API and trying to run on the old API level, it won't work. Simple reason. So pretty logical, but important to understand. The next is a version in Akash tablet. I'll just quickly show you how to check it. Let's go to the settings. I'm just going to settings, then in settings there is about tablet. So can you see this? Android version 4.0.4. So this is what I am talking about. You should check your device version and then only start programming. And also one more thing, there is a kernel version 3.0.8. This is important if you want to have Android custom image for your device, but let's not go into that right now. Let's come back to our slides. So the big picture, this is actually really big, it's not coming in the one screen. So you can get this diagram on developer.android.com, but let me just show you that there are 3 different colors and 3 different stacks. So what we'll do is we'll go to bottom up. The bottommost stack is a Linux kernel, then there is a libraries, and then application framework where your application actually sits. we'll go through the one by one layer because it's not anyway visible in this diagram. So let's look at the red layer, the Linux kernel. So as I have already told you, and most of us already know, that it runs on the Linux. Basically it gives its hardware abstraction layer. So why Linux? Several reasons. Again, Linux is an open source, lot of things have been already explored about the Linux, so it gives an advantage. Second, Linux has such a strong kernel, such a strong driver model, which makes even Android a portable OS. Because I mean, as all of us know, Linux runs on any platform. You just name it and it runs. So the objective of Android was also to run on many different devices, and this both objective came together. That's why they have chose the Linux. As a user, you will never see the Linux subsystem. You will always see the top layer, that is applications. The Linux is doing its work at the bottom. What is it doing, why it is important, we'll just see the later part of this session. Then there is some, on Akash tablet I have already shown you, Linux kernel version is 3.0.8, and there is a command using which you can open up the Linux shell. This is the ADB command, it's an Android debug bridge. Basically a very versatile, useful command tool which connects to your emulator or your connected device. I mean, we will have dedicated session on this on day 3, and a very useful tool which gives you access to the Linux shell and to do lot of things. The session would be conducted by Shrikant on 3rd day, and it would be a really useful session for you to attend. Then next is a green layer. So on the red layer, there is a green layer which sits the libraries. So these are basically bits and pieces which Android people just borrowed from different open source projects and made available in Android. So if you check out OpenGL, this SQLite, WebKit, you must have already heard it with context of different programming languages. For example, OpenGL is widely used in C++. Whatever games you see, those are mostly developed using C++ in OpenGL. So these are just libraries which Android people borrowed and made available on Android. On the right hand side, what you see is a pretty interesting part. That's a Dalvik virtual machine, a very well talked about. Basically a Dalvik virtual machine is a substitution of JVM, what we had in Java. You must have seen in earlier session there was a diagram where JVM was running the Java bytecode. So Dalvik virtual machine runs its Dalvik bytecode. Why it is required? We already had JVM, etc. We'll just see this after this slides. And as I mentioned, these are open source library used for different purposes. WebKit for fast HTML rendering, OpenGL for graphics, media codecs to support the media framework. Most popular media framework is supported in Android. Then SQLite database, this is a permanent data storage, how you can store a data on Android. We will have a session on this also. Let's complete our architecture diagram first. Then the blue layer, our application framework and application. So as a developer, you will deal with these two maximum time. You will avail the services provided by the application framework in your applications, like an activity manager. So I mean, in simple terms, activity is something on a screen with which user can interact, anything, I mean, which needs a user interaction. So whatever applications you see, for example, an Angry Bird application, so it needs that user to pull that and release it. So that's again an activity. So why this? I'm a lot of emphasizing on activity because this is what you will develop in the next session. A basic Android application program will have an activity, will have some user interaction. I mean, that's why, because we are dealing with a touchscreen environment. So everything has to be related to user, with comfort of user. So activity is important part. This is just 2 diagrams to understand what happens at the background. I mean, consider an email activity. So you open a email application, you get an inbox, right? You go to the compose email. So the inbox activity calls the compose email activity. So which means what happens at the background? Suppose my main activity is my inbox activity, which is calling the compose activity. So the main activity gets stored on the backstack and the activity 2 is pushed in. So this follows last in first out, a normal stack operation, And what happens? Activity 2, that is my compose email, is visible on my screen, and my main activity, my inbox activity, is in the background. So what happens when user clicks on the back button? When user clicks on the back button, the main activity becomes visible. That means my inbox will be visible. Sorry, my inbox will be visible, and my compose email activity would be popped out from the back stack. So I just wanted to make a note of it, that everything is getting handled by the activity manager, by your application framework services. I mean, you don't need to think about that, okay, I need to store my data, I need to show this activity, then I need to store which activity I had shown last. No, activity manager is doing everything for you. It's just that avail its use its services and just do it in your application. It is that simple. There are several other managers available, like content providers. Content provider basically gives you the data which is shared across the applications. If multiple applications wants to share some common data, then this is the place which you would like to go. Then there are other things like notification manager. If you have a smartphone, you must have already noticed you get a lot of notifications that you have a missed call, the battery is low. So this everything gets handled by the notification manager. And on top of this those are our applications, what you actually see. You must have seen in tablet also, there is a default browser, there is contacts, there are a lot of other things. So that's it about the architecture. Let's go next. That this is actually to show how process differs in Java and at Android in Dalvik virtual machine. So basically at Java what we have is, you have already seen, let's just see the left hand side diagram, let's concentrate on it. The Java source code, then the compiler bytecode, Java bytecode runs on the JVM, straightforward. What happens at the Android side? At Android side, we have a Java source code, we have a Java compiler, we get Java bytecode, then there is a DEX compiler, a special compiler which converts it to the Dalvik bytecode, and this Dalvik executable runs on the DVM. Now, this is what marked in red is something new steps which Android people introduced. Why it is required? Basically, a Java compiler, or rather Java bytecode itself, is a very verbose code, a very heavy code. If you try to decompile Java bytecode, you will get everything back as it is, right from your code, your resources, your things, everything. So, I mean, this is not possible to run on the smartphone or a tablet, where we have a power issue. A power optimization is required. You cannot run applications which are very consuming heavy powers. You have to consider that. So that's why they come up with this DEX compiler and this optimized code. This code basically optimizes Java, basically Dalvik bytecode optimizes the Java bytecode at several layers. And if you try to decompile, basically to decompile Dalvik bytecode is pretty difficult, and if you succeed in that, you won't get your Java source code back. There will be a lot of assembly code which you have to do a lot of other things to get your code back. So basically it does a lot of optimization to give you a small and optimized code. Let's go next. A very well-known difference between the DVM and JVM. So why I am emphasizing so much on DVM, JVM? See, because it's important to understand that yes, Android is based on Java, yes, it follows Java syntax, yes, but there are some differences than the Java, and this is a major important difference, because if we start using JVM on tablets and smartphones, your application will start crash, definitely. So this is important. Then, so DVM follows a register based architecture. So being I guess engineering student, you must be able to understand what is a register base, and JVM follows a stack base. I just have a small example to show you what is register base and stack base. So basically this is a stack base. So here is my program. I am just adding simple two numbers. I have my stack pointer. Stack pointer is here, right? And just to add simple two programs, I need these 4 lines of instructions, that is pop 20, pop 7, add 20 and 7 and store the result and push the result back. So 27 is pushed back. So just to add two numbers, I have to follow 4 lines. Whereas in register base, what happens is a single line of instruction will do your work. Add R3, R1, R2. R3 is my destination, R1, R2 is my source. So add R1, R2 and store it in R3. This is a diagrammatic representation. So it is adding 5 and 30 and storing it in 35. So what happens in register base is you need to give directly the address of register. You need to give the register name over there. So the length of instruction definitely increases, but the number of instruction decreases. That's why DVM follows the register based architecture, because it has the less number of instructions. So here is the difference clear. Number of operations in DVM would be fewer as it follows register base. In JVM it would be more because it follows stack base. And the file format I have already talked about. See, JVM it is known dot class. Basically this .dex is a Dalvik bytecode. So your source code in Android gets compiled to the .dex instead of class because of the Dalvik compiler. I have already shown you, because there is one more step. This is Dalvik bytecode, and this Dalvik bytecode nothing but .dex file. So we have covered this. Let's go ahead. So as I mentioned to you, yes, Android is based on Java. It follows Java syntax. It follows a lot of things in Java, but there is difference. So Android Java consists of Java standard implementation minus AWT swing plus Android API. So AWT swing, if you have worked on it in Java, it's not supported in Android. It's completely removed. They have come up with their own UI, which is part of Android API. And why this Android API was added? Because of touchscreen. I mean, we need extensive touchscreen support when we are dealing with Android, because we are talking about the smartphones and tablets. So this was required. So they just removed this AWT swing and added an Android API. So this is how the standard Java and Android Java differs. So you will see lot of Java APIs in Java is not supported in Android. This is the reason. So let's go next. These are some out-of-box feature what Android gives. What Android gives us, like application framework enabling reuse and replacement of components. Now this is pretty interesting feature to understand as a developer. So what it mean by it is, there are so many applications already available out of box for you. So whenever you want to use any application, you don't need to code for it. For example, in my application I want to use a camera. My application requires that camera should be open, it should click a picture, it should give me back. I don't need to write a code to access the camera, store the image, nothing. It will be handled by the camera application altogether. There would be an intent, or rather you can say there would be an activity which will do it for you. You just need to call it in your program. So this is a reusability. It uses, extensible reusability framework in it. And it is, you will see that there are so many complex applications, but they are so easy to code. So this is about the application framework reusability. Then we have already seen the DVM. Then there is optimized graphics support. It has to be there. The UI has to look very cool and attractive. So optimized graphics support like 2D, 3D, OpenGL support. There is a SQLite for the permanent data storage. We will have dedicated session on SQLite, how to access, how to store data, a very useful one. Then I already told you there are almost popular media formats are supported in Android. Then there is these three features, the last three feature depends on your hardware manufacturer. So if they have given it, then only you will have it in device. That is a GSM telephony, Bluetooth, 3G, Wi-Fi direct, hotspot, camera. So you can just go see at the glance that how much is there in Android. Whatever you think of it, it is there. Everything is supported. It's just up to you to how to use it. So these are Android features, and this is our Akash tablet features. Our Akash tablet feature, ICS, then optimized graphics support. We have Wi-Fi, which you must have already connected during the clicker quiz. We have camera, accelerometer, SQLite, media support, and lots of them. The application fundamentals. Now, see, when we install our application on the Android device, it is in the format of .apk, which is nothing but an application package file. What you see, I don't want to relate. Technically it would be incorrect, but what you see on .exe on Windows, what .exe does, it installs something. So similarly on Android happens with .apk, but technically it's incorrect to relate, because .apk is more like a .jar file in Java. It is a compressed format, that's it. So it's like a zip package format which is based on a jar. So basically your .apk will hold all these things. How your .apk gets created. You have a Java source code, it gets converted to .dex, and after .dex it gets converted to the .apk. So .apk will have, along with a code, lot of other things. There are resources. What is resources? Anything other than your code would be resource. You know, you want to play some video, you want to show some images, you want to place some file, anything, it would be in the resources. Similar with the assets. Then the some certificates if your device needs to sign. Then the manifest file. Manifest is a pretty important file in application because it's like a controller file, you can say. It defines lot of system properties. It gives, you know, permissions to your application and lot of other things. For example, as I mentioned earlier, I have an application where camera needs to be accessed. So I have to give my permission in manifest, then only the Linux kernel will understand that okay, this application needs a camera. So this is what .apk holds, and what happens once .apk is installed on the device. As I mentioned that, you know, although as a user Linux kernel doesn't come into the picture at any layer, but this is what it does. Once it is installed on a device, every application will have its own user ID. It will sit in its own security sandbox. It will have its own virtual machine. It will have its own Linux process. So if you understand this, every application will run in isolation compared to the other application. So two applications won't interfere with each other. So it's a great security mechanism. I know we are running out of time. Let me just cover up quickly rest all things. Android application components. Now, as I mentioned earlier, these are basically programming building blocks in Android. So you compare with a Java, what will you think a programming blocks in Java? A classes for desktop application, JSP servlet for web applications. Now here we are talking about a completely different environment. Android was developed for this touchscreen devices, which are smartphones and tablets. So what do you need on this? So you need something, you know, where user will interact, user will touch, something will happen. You will need something where, you know, the notifications are coming that, you know, okay, your battery is getting low, you have a missed call. You need something which is, you know, running in the background. For example, I am upgrading my software. So this has been developed with that aspect. It's not, I mean, with a Java aspect, it's a different one. So what is activity? So these are basically 4 blocks, and let's just see quickly one by one, because today in the evening you will have dedicated session on this where you will actually code this, run it and see it on your device. So basically activity is nothing but something which needs a user interaction. It's a component which provides a screen with a user can interact in order to do something, and it is implemented as a subclass of activity. So your first program will start which will extend our activity. Alright. So next is the services. Services, as I mentioned, something is happening in background for a long time. I am upgrading my software. So that's what a service is. Again implemented by the subclass of service. Then the content provider. Now content provider is an interesting part. I mean, it manages shared set of application data. I mean, consider application which is a to-do list. I have marked a to-do list and I have, you know, marked that okay, I have to call someone at this time, I have to do this, I have to do this. And if other applications needs to access that corresponding status, that whether I have called that person or not, I had my lunch or not, then yes, this is the thing which you will need, a content provider. So, you know, my to-do list can share its status with rest all applications whenever required. So this is a content provider implemented by subclass of content provider. Then there is a broadcast receiver. It is a component that responds to the system-wide broadcast announcement. Consider an example, if I have downloaded some file and all application needs to understand, okay, now for example, any player, I mean some VLC player is available for you. So if I have downloaded that VLC player and all application needs to understand, for example, my custom application needs to understand, okay, VLC player is there, I can play my video. So this is the thing. I mean, in your application, you need to implement a broadcast receiver which will receive this notification that, okay, it has been downloaded, it is ready to use. And this is just a last slide for you. Okay, this is the activity lifecycle diagram, a pretty huge one. Okay, so whatever you see in the gray box, these are nothing but methods which you can actually implement. For example, it starts from top to and goes bottom as activity starts. So first would be on, the names are self-explanatory, you can understand by reading it. It's on create, then on start. So activity will be available for user interaction after on resume. Once you do the on resume, then activity would be available for user to interact. So it can go for on pause, if you know some application with a higher priority needs some memory, or it can go for a on stop, then on destroy. So I mean you can see these are so important methods for I mean we are talking all the time about the performance optimization, the power optimization and etc. So for example on pause I am using a file resource, so I should release it. I mean the first and foremost thing when you will deal with Android application is never preserve your resources whichever you are using. Always release it when it's not in use. So you know on pause you can just release your resources, you can release your file object. So that will reduce the burden on the application and the power consumption. So this is it. I won't go into the detail now as we are running out of time. So let's go to the summary. This is all we have learned, a lot of things rather. I hope it was a useful session for you. And these are some references. So basically you just need to go to developer.android.com. This is a Bible for Android developer. You don't need to go anywhere else. This is the first and foremost kickstart for you. And yeah, thank you so much for listening.